Now, this next presentation, well, it's a big idea in a small package. Perhaps this is how we can put it. We're looking at the concept of if engineering itself had its own general intelligence. I've got an expert here who came all the way in from the USA to tell us about this here today. It is my pleasure to welcome to the stage Dr. Mok Oh. Please come on up. Round of applause. Yes, and I will give you, thank you, I will give you this as well. All right, he's just gonna get set up. By the way, he is with Foundation EGI, and of course has his own setup here, so we'll let him just get going with that. And while he does, I'll quickly mention, by the way, he has an MIT PhD, was a chief scientist at PayPal, and like I said, came in all the way from the USA with Foundation EGI to share this with us here today. So please, over to you. Well done. Take it away.
Thank you so much, Margot. Okay, how's everyone doing? I plugged in my...
Yeah, you do.
Okay.
From you.
No input from me. Hold on a sec. Let's try it again. Okay, here we go. Can you guys see my slides yet? Okay, excellent. There we go. Thank you. I'm here to talk about realizing engineering general intelligence. And it's our vision to realize this, and it's been for the last couple years or so after we founded the company. To realize this dream, we brought together one of the best teams in the world. My background's in a lot of research, started companies 5 times in startups, as well as lots of M&As, a couple M&As, IPOs, and some failures as well, of course. 30 years ago, I met a guy named Wojtek Matusik at MIT. He's my co-founder and chief science officer. He's a professor at MIT teaching at CSAI Lab, as well as mechanical engineering. And he and Mike, who worked together for about 10 years, they wrote a paper called How Can Large Language Models Help Design and Manufacturing for Humans? And really, really in-depth study, and from which we were inspired to start a company. To realize engineering general intelligence as well, we raised, of course, a decent chunk of money, and we will continue to raise a lot more. And if you are any of these companies on the right side of things, please come and talk to us. I also have Kyle and Harshit over here with us. But we do have Fortune 500 and even 50 companies with us as our customers. And the way I think about it is we're fundraising even more in order to give value to our customers. And in many ways, you get our value for in a subsidized way, I guess. Of course, we built our whole new stack and a platform that is deterministic, precise, and atom-based. What does that mean? AGI, or large language models, typically are more text and pixel-based, that's input data, and there are certain limitations to that. It's wonderful, but there are certain limitations. If you think about an engineer, if you have a chief engineer, all that knowledge in the brain and all of those, not just data sets, but years and years and decades of experience, those models are not necessarily built into the AGI models. What we're building here is something that is physically viable. It works with your data, with subject matter expertise. It's deterministic, traceable, verifiable, version controlled, et cetera. I'll tell you a bit more about it. And outputs are something that is immediately useful for all of our enterprises. Of course, we built applications on top of it. So I'm going to showcase a few of them today. I'm going to go straight into the demos. First is I'll show you something in the training side. Of course, we ingest a whole bunch of data. We have our own, as well as we have our synthetic data, from which load it to the cloud. We do a bunch of processing, cleaning up, and then I'll show you something where we actually cleaned up, correlated a whole bunch of things, especially in the manufacturing space. And from there, we'll show you a few more applications on top of that. So 3 applications, we got a lot more than this, but one is, of course, understanding parts. So once all of those data sets that you have are correlated, connected, and we know structurally what that, very clearly what that is, Then we can do things like, what is this part and what does it do? We can answer those questions. To process planning, if you have multiple of these parts or pre-assemblies and sub-assemblies, how do they come together and what's the best way to put them together? Of course, third is, of course, showing a full product of what it's capable of. And all of these are not distributed and very fragmented data sets. They're just one consistent data set that we've continually trained on. So there's a lot of benefit for that. Let me jump right into the demo. That's why I brought my laptop here. So first is, I've preloaded it, so I don't have any Wi-Fi issues here, but it's just like any other system. You start a chat, and you can pick up an application, and you go next, and you can drop in. You can also have our batch processes loaded from your buckets and have all of them just linked automatically. Then on the data set side of things, then next step is, of course, we always enable humans to look at and verify with a very human-friendly UI of what did we do, and please correct it if anything's wrong. So in this example, we have an engine over here, and here it organized it into multiple different pieces where you'll see a bunch of other assemblies and pre-assemblies here, which you can even open them up, et cetera. And if you look at, for example, this valve cover, there's a part number description, the component type, and a bunch of other things that we've actually calculated and computed, classified in the back end. So if anything's wrong here, the user has the very nice interface to modify and check and correct, which also gets then fed back in to our learning system. So one of the first applications that you have all these parts that came together, then what does it mean? So we get each of these parts, and we start understanding what they are. So in this case, you can see some sheet metal part over here, and this was done in about a couple minutes or so, and it's got a lot of annotations, PMIs, and what we can do here is it created 4 different views that are relevant to the engineers, 4+1 isometric view here. So then what you can also do is, when you have all of this information, what it actually did in the background, this is part of the secret sauce, is that it actually created this code right here. So this code, it automatically wrote 1,900 lines of code, from which then you can start talking to it. One of the prompts I asked is, tell me more about this part. And it gave me an overview of what the geometric features. From prompt, it knows what the geometry is, and you can ask to affect the geometry as well. You can go directly into the code. Everything's version controlled. Everything's auditable, verifiable, right there in the code. We're bringing actual bits and programming into engineering, into physical AI. So second application here is this. So once you understand all these parts, then how do you assemble and disassemble them? So we create a physically viable assembly graph, which calculates every possible scenario of how to assemble this together. When a human does this, it'll take dozens of people months to create one sequence. Here, we can do it in about a couple hours for a full car. And you can assemble them, disassemble them, give it different cost functions, and it'll create you a new whole set of how to assemble and pre-assemble and disassemble these things. Finally, of course, it's not just about the internals and the process of how to manufacture it, but same data set, you can go and show it on your website, go direct to the customers as well. So again, it's an interactive model of a car. You can say change color to black, where your customers, you can actually start talking to the product that you have. I can say open everything, and it'll do all these animations and showcase your actual product. Yeah, there's a lot more I can talk about. Unfortunately, I'm probably out of time, I'm 2 minutes out of time. But if you have any questions, we're around. Please come find us. Love to talk to you all, from startups to corporates, please. Thank you.